Alright, hello everybody. We are going to be looking at making enemies now. These are some pretty lame enemies, but it's going to be sort of the basis for many cool enemies to come. The important thing here is that we're going to be creating another class, and they have collisions, and they're going to collide with bullets. This is one of the most complicated things that we've done this year, so looking forward to doing that with you. I have recorded this video 3 times, so I'm just going to probably end up showing you the code of what's going on in here, because I don't want to type it again, and most of you know the story behind that. So anyways, here it is. This is the enemy class, and the enemy class, the story is that, like everything else in this project so far, the new classes all extend game object, and that allows this enemy to be put into the same list as the stars and the starfighter and the bullets and all that kind of stuff. And we're going to extend, or I guess that's not quite the right word, or to use that word, and we're going to add on top of the basic game object framework, we're going to add on a new variable. So enemies, in addition to all the variables in game object, they'll also have hit points, which I've abbreviated as HP, which I believe is the standard. Based on my Dungeons and Dragons experience, that is a standard shortening for hit points. Enemy is going to be, the constructor is going to similarly be flexible in the same way that bullet was. If you recall, bullet's got all these parameters, so we could tell a bullet exactly where to go and how fast to go. We can sort of specify that externally from the bullet. Same with the enemy. We're going to make the enemy really flexible so that we can spawn enemies wherever we want and be traveling as fast as we want them to, and we might upgrade this later on and change it. But I think that's a good policy for the enemies. And we'll make pretty basic enemies today, but sneak peek at future things. We're actually going to extend enemy for future classes to make bigger and better enemies, all sorts of different types. Here's sort of the basic values that we're going to set in the constructor. We're just going to set the x and y to the parameters and the vx, vy to whatever the parameters are, so that when we create an enemy, we can specify those in the other side. We'll take a look at what that looks like in a bit. And I'm just default setting the width and height to some number. This can change later on. It's not really important. We just need some number to go with. The alive variable should be set to true, otherwise it'll die as soon as created, which is a tragic story. And I'm setting the HP to be 10, just as a default number. You can set it to whatever you want. Then we got a show function. Nothing exciting here. Show function is just a rectangle, blue rectangle, I guess. And the act function. This is where the action is happening. So act function, since we're writing a new act function, we're overriding the game objects act function. So we're going to have to we're going to lose this code. So because enemies move, we're going to have to put that back in. And then we should probably make the enemies go away when they get off the screen. And I'm not 100% sure if this is the final version of this. There may be a situation where you want enemies to fly from the bottom of the screen and go to the top of the screen, or come from the left or the right. So this isn't necessarily the best or only way to do this, but right now the enemies come, the way I've designed them, they come from the top and they go to the bottom, like the stars. Excuse me. So I'm saying, if they ever go beyond the bottom of the screen, we'll set alive to false. So that's the story there. And here we go with the collisions. So this is actually pretty good. You might want to just stop there. Close your act function, close the class, and just run it. Actually, maybe I'll just mention how to get some enemies in there, and then we'll talk about the collision afterwards. Because the collision is the hardest thing we've done all year. So let's look at and see. Before we go further, you might want to put in your close brace and close the whole thing, and go from there. So here is the playing function. This is where me adds. Whoops, grammar failed. This is where I am adding in new enemies. So this is where I'm taking advantage of the parameters. So I'm just choosing where the enemy will show up. That's the middle of the screen in terms of horizontal direction, and this is the top of the screen in terms of vertical direction. That's just the X and Y. You can shake this up however you want. You can put random in here to make them kind of come out in random spots, and you can do all sorts of things. This is their VX and VY, so it's just not move horizontally, only go vertically. I think that's going to be great. And you just come straight down the line. You can see what that looks like right here. They're starting in the middle of the screen at the top and going down at that speed. And that's great. And then we just make that new enemy and then add it to our list. And then that is getting animated, right? So once it's in our list, our engine code is just going to eventually grab it, show it, and fix it, and then maybe remove it. There's one other part of this code, though, this if statement. This frame count is pronounced modulus, 50 equals 0. And the story with this is I want to not have an endless stream of enemies every frame. The stars are good that way. I'm just adding a star every frame because I want a lot of stars. I don't want a lot of enemies. So I'm using frame count modulus 50 equals 0. So what this is doing is checking the frame number. So when the program starts, we start at frame 1, and then every new animation frame, it just increases by 1. And so I only want to add an enemy on frame 50, frame 100, frame 150, frame 200, and so on. So this is a way to check to see if the frame is a multiple of 50. Modulus, I'll just type in here in a comment, modulus is an operator that finds the remainder of a division. Although it looks like the percent sign, it has nothing to do with percentages. It's all about taking frame count, dividing it by 50, and instead of getting the quotient, it gets the remainder. And guess what? If you divide a number by 50 and the remainder is 0, I guess that number is a multiple of 50. So that's how it's working. And if you wanted to make it come out slower or faster, you could change that number to be whatever you want, to make it come out on only the 100th and 200th, 300th frame, and so on. You could slow it down or speed it up by changing this number here. So that just limits how many I get, the speed at which they're generated. Alright, so now that we have sort of uncovered the basics of the enemy and how to add them into the world, I guess, into the running game, now we got to make them shootable. We have to make it so that we can shoot them, and the story is basically this remaining part of the act function here, which has been secretly hiding down here. So I'm going to explain what this is. We'll reveal it. Whoa, there it is. This little loop is a loop that will go through every object in our array list of objects. It's going to look for bullets. If it finds a bullet, we're going to give it a different nickname and cast it to be a bullet. We'll talk more about that. And then we'll just use our distance collision code we've been using since the Pong project to check to see if that bullet is intersecting with us. And if it is, there'll be consequences. So that's the overview of how this is working. So I'm going to go into more detail now. The for loop is a new thing. It's actually a for each loop. And you'll notice that we don't have int I equals 0. There's no while. There's no I equals I plus 1. This is a special loop for processing arrays and array lists that are full of stuff that are, you want to go starting from the beginning and going to the end and look inside of every single object. So it's called a for each loop. And you don't need to use I. There's no index required. This OBJ thing, it's going to, every time this loop happens, it's going to be a different object each time. It'll start with the first object, and then become the second object, and the third object, and however many objects there are, go all the way to the end. So then, each time, we'll just check to see if OBJ is a bullet. This uses the instance of keyword, which is fantastic. It can test to see if a particular variable is of a certain class. So, objects can be all sorts of things, right? They can be stars, they can be starfighters, they can be bullets, they can be enemies. So we want to only find the bullets, because we want to see if we're being shot by a bullet. And so we are going to then get the bullets. I guess we don't... let me start again. we're gonna what's called downcast our object to be a bullet, because right now it's a game object. This is a really annoying little piece of syntax here that is kind of a Java requirement, and there's good reasons for it, but it's not really part of the curriculum, so I won't go into it too much at this time. But just so you know, right now, object isn't a bullet, so it's not going to have all the things we need. So we're just going to cast it to officially be a bullet, and we'll give it a new nickname, which is B. So B represents the bullet that we found. And then you can just use B to refer to that bullet that we found, and we can do, this is probably more familiar code, we can check the distance between the enemies x and y and the bullets x and y, and see if it's less than the sum of the radii of the enemy and the bullet. And actually I should just pause for a minute, because you might be like, radii? What's going on? We have rectangles, not ellipses. And it's mostly for convenience sake for our rendering engine. Rects are a lot easier to draw. So we're just pretending that there's a circle that sort of surrounds our rectangles. And that's going to be our hitboxes. And unfortunately, it means that the corners of our rects will not be collidable. But I think that's a pretty minor problem. I don't think we're going to see that too often as a concern. So anyways, this is just the usual code that we've always done for Brick Breaker and Pong and other projects. So we're just testing to see if the collision is happening. If it is, we're going to drop hit points by 1. And if hit points are 0, we'll set alive to false. And in addition, we're going to kill the bullet too. And we can do that by saying b.alive equals false. So we'll set the bullet's alive variable to false. So this for loop basically applies this procedure if it comes across a bullet anywhere in objects. If there's no bullets, this will do nothing. If there's a million bullets, then it'll do this a million times. So you can see how this could start causing a little bit of lag. But that's how it works, and it works pretty good. As you can see in our game, we're able to, if you don't suck, you're able to like shoot these up, and you can see that the bullets are in fact dying, and the spaceships too, if you get enough hits on them, also die. So collisions are working. This is pretty phenomenally complicated code for a grade 10 class, so congratulations on taking this, and please ask questions about it. I'd love to be able to help you out if you are not sure how any of this is working. I think that's it. I think that's all we did for the enemy. We did not override the game object's isAlive function. We're just going to leave it the way it is, and that seems to be working pretty well. Okay, there you go. There are your enemies. Stay tuned for the next video where we're going to make more complicated enemies and waves of enemies.